This project comes in two halves: carbon monitoring, which works to quantify the standing carbon along the Savannah River and Winyah Bay, and sap flow measurement, which focuses on how trees are using water throughout the day and whether more sap flows up certain sides of a tree's trunk due to various possible factors. Understanding carbon monitoring and sap flow can help with natural resource management in the low country of South Carolina. The objective of the carbon monitoring project is to quantify carbon stocks in different components along the two river systems. These components break down into two categories: live biomass and dead biomass. In the live pool, we measured trees and shrubs, but we left out understory herbaceous plants like grasses due to very high water levels that persisted on study sites. In the dead pool, we measured all the downed woody debris, including stumps, snags, and fallen limbs. The Sapflow objective is to determine if the canopy distribution affects the rate of sap flow using sap flow probes that are inserted in the cardinal directions of a given tree. This has implications for modeling individual tree water use, as well as landscape level estimates of transpiration. Previous efforts have measured sap flow rates on the north side of trees, which minimizes solar insolation and exposure to the probes, but may cause underestimates of true individual tree water use. The carbon monitoring project uses a paired plot design where each plot consists of two 20-meter by 25-meter subplots directly adjacent to each other. The project utilizes two transects, one along the Savannah River and another along the Winyah Bay. Each transect has 5 plots. This summer, we worked on finishing the setup of the head of tide and non-tidal plots in the Winyah Bay system. To survey the trees, we measured the diameter of the tree at breast height and determined the percent cull. We then collected the litter fall in the litter collection traps at each plot in the Winyah Bay system, which was then dried and weighed. To survey the snags, we measured the height measurements and rated the level of decay. For the Sapflow project, we worked to deploy the first round of Sapflow probes into 12 trees. We deployed 3 battery stations that each controlled enough probes to measure 4 trees. Each brain required 3 deep cycle marine batteries to operate. Each tree had 4 probes inserted at the 4 cardinal directions. A cable was then placed from the probe to the brain, where the software would send electrical impulses to the probe and measure the rate at which the water cools down the probe. Groundwater wells were also placed in the sites near the brain to measure for any saltwater intrusion using a YSI device. The expected outcome of the carbon monitoring project is that with the rising sea levels, the biomass of the living trees will decrease. The expected outcome of the sap flow project is that the canopy distribution will predict the tree's sap flow. If the tree has a majority of its canopy in the northern direction, then more sap will flow up the northern side of the tree. In the future, there will be another round of deployment for the Sapflow brains, and the canopy measurements will be conducted by using various methods to find the footprint of the branches.